All right, so when I'm looking at this, now the change of position for RAM2 is going to be it's displacing itself in the negative direction. So rather than writing it just simply as 30 minus x, I'm going to write it as minus 30 minus x, simply because it's displacing itself to the left. And since it's moving to the left, this has got to be minus 12 times t. All right, so what I need to do is solve both of these equations for x. So in order to do that over here, what I'm going to get is I'm going to distribute the negative. So I have minus 30 plus x equals minus 12t. And then I got to add the 30 over to the other side. Okay, so now I have one equation for x, I have another equation for x, and just like you've done in your math class, set them equal to each other. So I'm going to say 10t, that's from this first equation right here, is equal to what I have above here, minus 12t plus 30. Then I add the 12t over, add the 12t over, that cancels that out, and I have 22t equals 30, and then divide by 22. So I get t is equal to 1.36 seconds as well. All right, so for the next one, what we need to do here is write out what we know about Fritz. So we know that Fritz the cat's fired upward with a speed of 30 meters per second, so that's plus 30 meters per second. And then at the same time, Felix is dropped. So Felix, what we know is that Felix's initial velocity is dropped from rest, so its initial velocity is 0. And then we want to know how far apart are the cats when Fritz, that's the first cat, is going at 10 meters per second down. So 10 meters per second down, we get the negative. So we know the acceleration of both cats is negative 9.8 meters per second squared. So the acceleration of this cat is also negative 9.8 meters per second squared. And so what we need to do is figure out how long does it take Fritz to get to going from plus 30 to minus 10. And you can kind of get an idea that it's going to be around 4 seconds. Then, in that time, where is Fritz? Once again, we expect that Fritz to be above where they started, just simply because it's not quite yet at negative 30. Negative 30 would be when they're at the same height. And then we're going to use that same time over here to find out how far down has Felix traveled. So let's start tackling the time. So I have v, v naught, a, and t. So I know that equation 3, which is v equals v naught plus at. I can solve this for t. I subtract the v naught, so v minus v naught equals at, and then divide by a. So I get my time is equal to my final, which is minus 10, minus my initial, which is minus a plus 30, so that all becomes negative, over negative 9.8. And so I get a time of, it's just a little over 4 seconds, and I got 4.08. So then in that time, I'm going to figure out where is Fritz. So the displacement, the fourth equation, v naught t plus 1/2 at squared. And then plugging in the numbers, I have plus 30 times 4.08 plus 1/2 times negative 9.8 times the 4.08 squared. Okay, so notice that what I end up getting here is that this is a positive term, and then this whole thing, because we have the negative in there, will be a negative term. So I'm basically going to take this, which is around 120, and subtract this, which that ends up working out to be 40.8. So this is 40.8, so I'm going to come down here. So 40.8 meters. So Fritz is above where he started by 40 meters. All right, and then I'm going to do the same thing over here for Felix. So Felix, same equation, but now the initial velocity is 0, so then it's just 1/2 at squared, since the v naught is 0, and then 0 times any time is 0. So 1/2 times negative 9.8 times the 4.08 seconds squared. So notice this works out to be a negative number, and so I got negative 81.6. So now I want to figure out how far they are apart. So Fritz is 40 meters above, Felix is 81 meters below. So what I'm going to do is simply take, I'm going to subtract them. But when I subtract them, what I end up getting is plus 40 minus a negative 81.6. And so the end result is they are 121 meters apart. What the next kind of conceptual follow-up question would be, as they are falling back down to the ground, what happens to their separation distance? Now, what we need to consider is how fast are each of them going, at that particular time. So one way to think about this is that it's going to take roughly 3 seconds for Fritz to stop. Okay? Because he's losing 9.8 meters per second every second. So roughly 3 seconds later, Fritz gets to its highest point, stops, and then starts picking up speed in the opposite direction. But think about what Felix was doing that whole time. Felix was picking up speed in the downward direction from time t equals 0. So basically what ends up happening is that Fritz gets a head start, and since they're going to be accelerating at the same rate, if at 3 seconds, Fritz is going already roughly 30 meters per second. So their separation distance will continue to increase. So for letter B here, it's going to be increasing as time goes on. All right, so we have two derivations coming up here, and for both of these, well, not both of these, but for most of these problems, it's all about the timing. Okay, so what we need to consider is what is going on with the coconut and what is going on with the freshman. Right, so the monkey is going to drop a coconut. The monkey needs to drop it at some distance x, some distance in front of where the freshman is. So the time that it takes to fall will be the same time that it takes for the freshman to walk that x distance. So that's what we're looking after. So how far in advance must the monkey drop the coconut? So we know that for the coconut, it starts from rest, it accelerates at g, it moves its change in position, and it's a vertical position, so we're going to denote it y, and we don't know the time, how long it takes to fall. So for the freshman, what we know is that the acceleration 0, its initial velocity is v. We don't know how long it takes the freshman to walk x distance, and its change in position, we're going to denote x. Okay, so a couple ways of looking at this, but what I'm going to do is first solve for t for the coconut. How long does it take the coconut to fall a distance y? And then plug that into an equation for the freshman. So for the coconut, we know that its vertical displacement is equal to its initial velocity times the time plus 1/2 at squared. And since the coconut starts from rest, the initial velocity is 0, and it's displacing what we're going to denote letter y, and then that equals 1/2 gt squared. If we do a little algebra here, we multiply both sides by 2, divide by g, and then square root. So I get time is equal to the square root of 2y over g. So what that means is that it will take radical 2y over g in order to fall some distance y. So for the freshman, we're going to use the same equation, but just looking at it in the horizontal as opposed to the vertical. Okay, and since the freshman is going at a constant speed, the freshman's acceleration is 0. So then the distance x is going to be that we have to drop it in far in advance, is going to be the initial velocity, which we're calling the letter v, times the time it takes the coconut to fall, which is equal to rad 2y over g. And so that is it. That is how far in advance in terms of the variables v, y, and g. And then we have a constant. Actually, it turns out to be the constant's radical 2. But that's your final expression. You don't need to simplify. That's the answer. Okay? I know sometimes in math class you're often asked to simplify your expression. All right. So we'll check back in a third video to finalize the last 2 questions. All right. Thanks for watching. Have a good night. Bye-bye.